Hey guys, I'm just going to do an example of how to draw double-sided frequency spectrum of an example equation, such as the one I've given here. Okay, so this thing can be kind of tricky to understand and get the hang of, but I think once I show you step by step, it shouldn't be that difficult. Okay, so firstly let's properly expand our equation, because you can see we have 10 times 1 plus 0.5 cos 2 pi fmt times this whole thing. Maybe I'll make these brackets a little bit clearer to understand. There we go. All this both times by 10 and cos 2 pi fct. Okay, and our fm is 1 kilohertz and our fc is 100 kilohertz. Okay, let's go ahead and expand it. So we have our, of course, x102 equals 10. Let's combine these two together. So 10 10 cos 2 pi fct times 1, so that's just our term, and then another term which is 10 times, well, this term times 0.5. So we have 5 cos 2 pi fct cos 2 pi fmt. Bit crowded there, but there we go. So we're almost there, but analyzing this bit is going to be tricky, so we have to use a trig identity, which I'm going to write down here. So 2 cos A cos B equals cos A plus B plus cos A minus B. So I think you can see where we're going with this. We're gonna analyze this now. So because we have it, see, in this form here, so to get it into this form, we have to first divide this section here by 2, because our coefficient is not just 2, it's 5. And since 2 becomes, well, 1 here, you divide it by 2. So let's write that now as 5 on 2. We can, it's probably better that we just leave it in this format, because we're going to be dividing by 2 again later, so it's just easier to leave it like this. And then we'll have cos our fc and our fm. So let's write that. Let's sub in our fc and fm though, just so we can we lose all these jargon numbers, jargon letters. So we got first, let's write this here. So this is A, and this is our B. So our A is in this case 100. So 100 plus our B, which is 1. Let's leave this in terms of kilohertz, just so it's not as messy. Okay, so that's our first bit of the equation. Now let's do it again for the second bit. So cos, oh, don't forget our coefficient, it applies to both. So 100 minus 1. There we go, our FC minus our FM. Okay, so let's just write this out again with our simplified. So 101 and 5/2 cos 99. Don't forget it's in kilohertz, we're just doing this bit of shorthand. And oh yeah, we can let's just 2 pi is there, but you know, it doesn't matter a whole bunch in this analysis, but it's still important to have it there. Okay, let's write out the whole equation again so we see what we're dealing with. So 10 cos plus, because this didn't change, only this bit. So using our trigonometric identity, let's write this. Let's all forget our t's. Okay, there we go. Now we can use our Fourier transform to put this in a form that we can then draw our spectras from. So let's use, I think it's the sifting property of the Fourier transform. It looks something like this. Delta these deltas here is what give us the amplitude spikes, because that of course is a impulse function. F plus FO. Okay, so now let's apply this in here and take the Fourier transform, and let's start with this first term. Let's do it in little pieces. So now our x will be x1 of f, and let's go with this our first form. So as you see, it fits quite nicely, but we have a 10 here, so we need to divide a 10 by 2. So let's just write it, yeah, let's keep it like this for now so we can see what we're doing. And then we have delta f minus our FO, and our FO in this case is our FC. So and our FC is 100, so let's write it like that, minus 100. Don't forget it's in kilohertz, of course, just leaving it out for brevity. And now the second half of our 10 is also 10 divided by 2, delta sign, F plus 100, which is our FC. Okay, so now that's our first term done. We've got to do the other two. So I'll just put a little plus here, and I'm going to take it down onto here. So it's actually, maybe we have enough room over here. So same sort of thing again, except our 5 over 2 now becomes 5 over 4, because we have to divide it by 2 again. And then we'll put our delta F minus 101. There we go. That's one part of this second term. So another plus 5 on 4 again. Our delta F plus our 101. Okay, there we go. So now we've done the 10 cos term and the first 5 on 2 cos form term. I'm just going to put a plus here, and let's continue this equation at the bottom here. We'll be doing the third term. So it's pretty much exactly the same as the second term we just did. So we can just rewrite that again, but be careful not to get mixed up because our FO term is different. So we've got 514, our delta F minus our F term, which is 99, then plus 514 delta F plus 99. There we go. So that's our new equation. And now we can easily take all these little numbers and we can draw the frequency spectra for that. Okay, so let's draw it here. Say x1 of f. Excuse my drawing. Hopefully you can get that nice and straight. Ooh, I'd have to turn it around. Okay. Not the most level thing, but that's all right. We'll get the idea. So our 10 on 2, so the coefficients at each, or in front of all the delta signs, are our amplitude. So 10 on 2 is our, 5. And 5 on 4 is 1.25. So let's put that somewhere around here, 1.25. And then put F here as our frequency. And let's mark our x-axis. So all these will be places on the x-axis. So let's start with the positives first. So we'll have positive 100 kilohertz. Let's just put that there so we don't get confused because we are talking in terms of kilohertz. Then we have positive 101 kilohertz. So let's space it out a little bit more. 101 and our positive 99 kilohertz. Okay, and then so see positive here, and positive here, and you see there's the exact same, but in the negative. So let's go ahead and put that in the negative side. I'll try and place them equally. So we have minus 99 kilohertz, minus 100 kilohertz, and minus 101 kilohertz. Okay, now this is the easy part. We can just draw the spectra at the height at which their coefficients represent. So for our 99s, they're all at 5/4. For our 100s, they're all both at 5, or 10 on 2. And our 101s are also at 5/4. So now we just have to connect them up. And there you go. Now we have our double-sided frequency spectra. There you go. I hope that helped you out. Definitely took me a few times to figure it out, but yeah. Hopefully it was useful to you. Hopefully you could follow the steps easily enough. There you go.